Okay, so first of all, good morning to all of you. So in the last session or in the previous session, we seen the conductor size calculations for the residential purposes. So in the last session, we seen one example of the conductor size calculation for underground cable. But that was too fast. That's why I'm repeating that question and that points once again. So which are the factors that are affecting on while selecting the size of the conductor? Okay, so the factors are listed here. So first of all, current carrying capacity of the cable. That means whenever we are finding the current, actual current required to run that load. So depending on that, we are selecting the size of the conductor. So first major point is the current carrying capacity of the cable. So whenever we are finding the current carrying capacity of the conductor, then and then only we can select the size of the conductor. So first point is the current carrying capacity of the cable. Then next voltage drop. So voltage drop is we are calculating to check that is that voltage drop is falling within permissible limit or not. If that voltage drop is falling within permissible limit, then and then only we are selecting the cable. Otherwise, we are going to select another cable. Okay. So voltage drop is it also affects while selecting the size of the conductor. And then minimum permissible size. So for every conductor there is minimum permissible size. That means the for carrying minimum current also we are selecting the minimum permissible size that is fixed. Okay, then material of the conductor. So whenever we are selecting any conductor for particular current carrying capacity, so it also depends upon which type of the conductor we are selecting. Okay, so if you are selecting the copper conductor, then you have to uh, select the size or refer the table for the copper conductor uh, specifications. And if you are selecting the aluminum conductor, then while selecting the size of the conductor, you have to refer the aluminum conductor size calculation table. Okay, so in the residential purpose, what we are doing for calculating the voltage drop, we are using the formula. That means which formula we were used for calculating the voltage drop for the residential purpose? Permissible voltage drop. Which formula we were used?
One plus 2% of supply voltage.
Hmm. And if the load is industrial, in that case, what we are doing?
1 plus 5% of supply voltage.
Very good. Okay, by using these formulas, we are calculating the voltage drop. Then we are calculating now conductor size calculations for the underground cable. So here again we have to change the formula for the transmission and underground cable selection. The voltage drop should not be more than 12.5%. That means the what is the permissible voltage drop? Permissible voltage drop is 12.5% of the total voltage. So for carrying the voltages, that means the for carrying the that much amount of the load, how many voltages are there? Up high voltage lines are going. That means through underground. So 11 kV, 33 kV, like that. So we have to consider the voltage drop of 12.5% of that voltage level. So how much may be the voltage level? 11 kV, 33 kV, etc. If there is a distribution line, so the in the question itself it is mentioned that is that line is transmitting power or distribution line. If there is a distribution line, the voltage drop should not be more than 5%. So these all things you have to keep in the mind while solving the example or the question. Okay, So first 4 points are same for all conductor size calculation. That means while calculating the conductor size of the for the residential purpose, industrial purpose, underground or overhead. These 4 points are will be similar for all conductor size calculations. So someone just read or tell me these points so that all will get familiar with these points. Current carrying capacity of the cable, voltage drop, minimum permissible size, and material of the conductor. If the question asks for the 4 marks, you have to mention these points and you have to write 2-3 lines below every point. Okay, so who will read these points once again? Factors affecting on the conductor size calculations for underground cable. Anyone from all of you?
Current
Hmm.
carrying capacity
Hmm.
of the cable, voltage drop, minimum permissible size, material of conductor that is copper or aluminum. The permissible voltage drop for whole different stages will be such that for transmission of underground line should not be more than 12.5%. For underground distribution line should not be more than 5%.
Okay, so up to this point, everyone is clear? Okay, so there are different tables for different conductor size calculations. That means the for residential purpose there is different table. Uh, for underground cable there is different table for selecting the size of the conductor. Okay, so here for the voltage level up to 11 kV, this is different table. So if there is a voltage drop up to 11 kV that is mentioned in the question, voltage level up to the 11 kV, then you have to refer this table while calculating the size of the conductor. Okay, and while selecting the size of the conductor for higher voltages, always prefer 3-core cable. Okay, or multi-core cable, not only 3 multi-core cable, rather than selecting single core cable. Single core cable you can select for the minimum voltage levels. Then next, this table is for up to the 33 kV voltage levels. Uh, you all take first screenshots of these tables, so it will be easier while solving the questions. Have you taken screenshot?
Yes, ma'am.
Next for 33 kV also. I will provide you all these tables. I will make one PDF and will provide you all these tables. Okay, just take a note here So whenever you are selecting a size, so just keep in the mind here column is given for the ground. If that cable is going through the underground, then you have to select the size from this column. Inductor, if there is induct mentioned, then you have to select this column. If that conductor is in open air, then you have to select this column. So don't select like anyone from this, like that. Next, so uh, while calculating the voltage drop for the transmission cable, you have to use the formula for we know voltage is equal to, what is the formula? I into R, isn't it? If there is a three-phase voltage or for higher voltages, then you have to use root 3 V into root 3 I into R. So R is sometimes resistance is given in the question itself. If that resistance is not given, then you have to select this cable, this table. Okay. For how much size you selected for the cable. Suppose you selected this size of the cable, then you have to refer the resistance of the wire. If there is a single core, you can select it from this column, and if there is a multi-core, you can select it from this column. Always I think you have to use this column only. Okay, we will move towards the problems now. Okay, someone read the question. Someone read the question first. Okay, if you are not responding, I will take your name
Yes,
random.
calculate on the basis of voltage drop the size of underground cable to be laid for transmitting electrical energy at 11 kV from the substation at the distance of 500 meters of capacity 300 kV.
Okay, which type of power is given here? Apparent power is given here. So here power factor will come here or not? In the formula
Yes.
power factor? Yes?
No. No, ma'am.
If there is active power, then power factor will come. If it is mentioned in kilowatt. If it is mentioned in VA, we have to select only voltage and current. Okay. Now, first step, we will put all the given quantities. What are the given quantities here? Voltage level is given here, 11 kV. Then next, length of the cable or distance. It is 500 meter. Then power is given 300 kVA. Okay, now what we have to calculate first? First we have to calculate the current carrying capacity of the cable. That means that depending upon the how much current obtained here, depending on that level, we will select the size of the conductor. So before that, we will first step we will find permissible voltage drop. So here transmission cable is mentioned here, transmission underground cable. So which formula will come here? For finding permissible voltage drop?
12.5% of
Total voltage. This is percentage, not divided by. How much is the answer?
1.317 kV.
Okay, this is permissible voltage drop. Now we have to calculate the size of the conductor. Next step, select size of the conductor. Okay, so while for selecting size of the conductor, what we have to find? First we have to find the current. So which formula we have to use? We know formula for power. P is equal to root 3 V into I. So this is the formula for power. Now we have to rearrange this equation in such a way that we can get the current term. So I is equal to, so these two quantities will go towards the denominator of the P. So P divided by root 3 into V. This V is nothing but the total voltage. Shall I write here? I will write here only. I is equal to, how much is the P? Power 300 kVA. 300 into 1000 divided by root 3 into voltage. So how much is the voltage? 11 kV. 11 into per k 1000 we will write here. This 1000 will get cancel each other. Now tell me the answer.
15.75 ampere.
Okay, very good. 15.74 या 75 ampere, whatever answer will come here. So that we will write here. Okay, so this is the actual current flowing through that conductor. Now we have to consider overload capacity condition also. Okay, so for selecting the size of the conductor, we will consider 20% of the overload. So allowing 20% of the overload. Now how much current will come here? I is equal to 20% of 15.75.
Three point 15 ampere.
Okay, 3.15 ampere is nothing but what? This is the 20% current. Okay, now for finding 3 point, how much?
15.
15 ampere. Okay, this is 20% of this whole current. Now total current, total current means what? This current plus 20% additional current. Total current 15.75 plus 3.15. So how much is the total current? 18.9. Is it correct? 18.9. 18.9 ampere. Now this is 3 phase. That's why we have to consider current rating of carrying this total current. That means 18.9 multiplied by 3. I'm not having calci right now. You just calculate and tell me that how much current carrying capacitor should we select.
56.7 ampere.
56.7 ampere. Okay, for carrying the 56.7 ampere in the 11 kV underground cable, which conductor should we select? Just see this table with careful.
25 mm square.
25 mm square. Okay, very good. Single core, yeah, 3 core. Which
3 core.
column you refer? 3 core armored cable. Okay, so which column you preferred? First, second, third? I'm asking column here, current rating column. This is first, 2 and 3. Which column will you prefer?
First.
So in the first column, 3 core armored. So nominal area in square meter, it is 25 square mm. 3 core armored. So you can write here sentence like here I'm referring to the table. Referring to the table, which conductor we selected? Aluminum conductor. Aluminum conductor, paper insulated. So the specifications are mentioned in that table itself. Paper insulated, or which type insulation is provided. Paper insulated. Paper insulated 11 kV underground cable. Okay, it is seen that who's that? Jairam Londe.
Yes, ma'am.
Mute yourself.
Yes, ma'am. I have meant.
It is seen that 25 square mm. Underground cable is suitable for this load. Underground cable is suitable for this load. मॅडम लेक्चर चालू आहे. One second, I will come. Okay, so after selecting the size of the conductor, now we have to find the actual voltage drop. So for finding the actual voltage drop, we have to check how much is the resistance of that conductor. So in the question itself, it is not shown the resistance. So we have to find the resistance per kilometer. Resistance per kilometer. For checking the resistance, we have to check the table here. You have to refer this table. So in that, area is mentioned here. What was our area? How much square mm? Swapnali?
Yes, madam.
How much square mm we selected the size of the
25.
conductor? 25 mm square. Okay. Then next, we selected this size of the cable. Now we have to check the resistance per kilometer. Okay. So how to select the check the resistance per kilometer? Okay. For single core, we have to refer this table column, and for the multi core, we have to select this column. Okay. Per kilometer, how much is the resistance of this cable? 1.102. Maximum allowable resistance per kilometer. By referring this table, we can get the resistance per kilometer 1.102. Is it correct? Okay. Then next, we know the distance. How much is the distance or length? 500 meter. Now we have to calculate the resistance. For 500-meter distance. Okay, here resistance is mentioned in kilometer. Now we have to calculate the resistance for 500 meter. So for that, what we will do, 1.102 multiply by how much is the distance? 500 meter divided by 1000. Okay, now tell me the calculation.
0.55 ohm.
Okay, so after finding the resistance, we can calculate the voltage drop. And that received voltage drop, we have to check is that voltage drop falling within the permissible voltage drop limit or not. So next step, this is the third step. Here we can write actual voltage drop. So what is the formula here? Now put the values. Here you have to note total current. So how much is the total current? 18.9 ampere. How much is the resistance? 0.551. Okay, tell me answers.
Eighteen point zero three. 16.69.
Something went wrong. Whose answer is 16 point?
18.03.
Hmm. Now this voltage drop is falling within permissible limit or not? What was our permissible voltage limit? Okay, so this is falling within permissible limit. So we can select the above conductor size. You can write one sentence at the last. The actual voltage drop is falling within permissible limit. So we can select 25 mm square aluminum conductor. Three core. Aluminum conductor. To carry given load. वायफाय चालू करावं लागेल. Okay, so all of you understood this numerical or not? Or is anyone having confusion while solving this question? Okay, only 2 students are giving responses continuously. What about others? No. Swapnali, are you clear?
Yes, madam.
Okay. Okay, I will give one example similar like this. I will change only power and you have to tell me the procedure for solving the example. Okay. Hmm. Who will tell me the procedure from start? Okay, someone just read the question and tell me the given quantities. What are the given quantities in this question? And what we have to find out? Who will tell me the answer? Shraddha, Vaishnavi. Don't tell me answer. Just tell me the same procedure as like last question. What are the given quantities here? Voltage is given. Then length is also given. Power is given in the kVA. So first of all, what we have to do? We have to write all the given quantities. V is equal to 11 kV. Then next, length of the cable is 500 meters. Then next, power is given 200 kVA. Next, what we have to do?
Permissible voltage drop.
We have to find the permissible voltage drop. I will not solve here. You have to do the calculation at home. That means this is the homework for you, because of our time is over. Our time is over now. So first of all, we have to find the permissible voltage drop. After finding the permissible voltage drop, what we have to do next?
Current carrying capacity.
Current carrying capacity. After that, we have to consider 20% more current. That means the overload condition we have to consider. After calculating the overload condition, we have to add that current or find the total current. Okay. After finding the total current, what we have to do?
For 3 phases multiplied by 3.
Then select the
from
size of the
table
conductor.
resistance.
No. Then most important
Size of the conductor.
size of the conductor by referring table. Then we have to check the resistance per kilometer by referring the table. After referring the table and finding the resistance per kilometer, if the distance is given in the meter, we have to divide it by 1000. Okay. So we have to find the resistance for the given distance. So how much is the here distance is not changed. So you have to use the same formula. Only you have to check the resistance per kilometer, multiply by 500 meters divided by 1000. Then you have to check the actual voltage drop. So for the transmission, root 3 I into R is the actual voltage drop formula. Then you have to put the values of that quantities. That means the current or resistance. After putting the values, you have to calculate the answer, and then you have to check the is that actual voltage drop falling within permissible limit or not. If falling within permissible limit, then there is no problem for selecting the given size of the conductor. Okay. Okay, just try to solve more number of the numericals by changing the values. Okay, we will stop here, and thank you for joining the session.